This question is from GATE Mechanical Engineering of 2015. This is question number 51 of set 3. The question is, for the linear programming problem, maximize z is equal to 3x1 plus 2x2 subjected to, so these are the constraints, negative 2x1 plus 3x2 should be lesser than equal to 9, x1 minus 5x2 should be greater than equal to negative 20, and x1 and x2 both is greater than 0. That means it lies in the first quadrant. Now the question asks, the above problem has what type of solution? Let's use graphical method to solve this problem. Now let's say this is x1 and the vertical axis is x2. So the first constraint, minus 2x1 plus 3x2 should be lesser than equal to 9. Let's draw this one. If x1 is equal to 0, x2 will be equal to 3. Okay, so it will be somewhat here 0, 3. Okay, and when x2 is equal to 0, this will be equal to negative 4.5. Okay, so somewhat here, but we are not supposed to go in any other quadrant since it is given that x1 and x2 both are greater than 0. That means it will be in first quadrant. Okay, so this line is negative 2x1 plus 3x2 is equal to 9. Now it is lesser than equal to 9. Okay, so lesser than condition, that means it will be below this curve. Okay, whatever the values, it must be below this curve and of course above this line and here. Okay, now let's plot the second curve. That is x1 minus 5x2 should be greater than equal to 20. So if x1 is 0, that means x2 is 4. That means somewhat here 0, 4. Okay, and if x2 is 0, so x1 is negative 20. So negative 20, it will be somewhere there. So the curve will be something like this. Okay, and of course it will intersect at a point. Let's say this point be P, and we can find the value of P, the intersection point. So x quadrant of P is around 2.14, and y is 4.43. Okay, and it is said that this should be greater than equal to minus 20. That means this belongs to the downward direction here. Okay, now if we try to find the intersection region, so that will be this region. Okay, this region it will be, but here it is not bounded. Okay, anywhere it is not bounded, so it is an unbounded solution. So option A is the correct choice. From the graph it is clear. Now here from this curve we can see the feasible region is not bounded. Okay, so it is possible that the value of object function, this function here z, this is the object function, it can go on increasing without leaving the feasible region. Okay, it can be there inside somewhere, but we cannot find the exact maximum value for this problem. Okay, that's why this is called an unbounded solution. So option A is the correct choice. For more information on this topic, you can refer to the NPTEL course, lecture number 3, Linear Programming Solutions, Graphical Methods, a lecture series on fundamentals of operational research by Professor G. Srinivasan of the Department of Management Studies at IIT Madras.